Alright, we're looking at question 11 here. If H2O, water, has a pKa 15.7 and HF has a pKa of 3.2, which is the stronger base, OH or F minus? Now, what they're pointing out here, or not directly, is that we're looking at the conjugate bases of these two acids. Now, what we can do to see this, what's going on with all these, if I were to rank acids by their pKa's and list the strongest acids at the top, these two would get listed something like so. Okay, so I have a HF with a pKa of 3.2 versus H2O pKa 15.7. HF is definitely a stronger acid. All right. Their conjugate bases, removing one H, would be these two that we're talking about. Now, these are bases because I just called them conjugate bases. Now, what's really neat on this, though, the strength of bases is the exact opposite always. And just because of that, we can define OH as a stronger base. Or, another way to see what's going on here, we're going to have HF, the acid that we have identified as a stronger acid, react with OH. And the reason I chose OH is I want the HF to donate its H and make water, this other acid. And then to complete this idea, the H goes to the OH, therefore this F is floating around. We have this for an equation using those two acids. Alright, now where this comes in handy, I can identify that as an acid, and this is the base form of it, and I can identify this as an acid and a base. But now if I rank our acids as the strong and weak based on the pKa's, I have SH as a stronger acid than water. And because the nature of how these reactions always go, that would actually mean that the OH is a stronger base as well. So I got two ways to explain this. First one's probably the easiest, and really it is as simple as if I see a very high pKa, I know that makes for a very weak base. So a strong acid makes a weak base, a weak acid makes a strong base.